Hello, everybody, and welcome back. It's Advent of Code again. Can you believe it? I'm so excited. It's my favorite time of the year. The snow is starting to fall outside, so the reasons to leave the house become fewer. Um, and now that we get fun coding puzzles that we get to solve in our favorite language, it really is the best time of the year. And of course, we got all the classics already set up. I'm sure I made myself a nice hot cup of tea that I can continue sipping throughout. Of course, don't worry, the reading cap is already back. We're gonna be doing a whole bunch of dramatic readings. You can see that Cody in the background also has their own little hat. So we're all in the festive spirit here. Yeah, and let me tell you, I don't wanna spoil too much, but we have a lot to look forward to in 2024 and the Advent of Code campaign that we're doing here. We'll be doing 12 streams, just like we did last year, and I am so excited about all the guests that we're gonna have. We're gonna have people from the Kotlin team, from JetBrains. We're gonna have people from the community. We're gonna see some familiar faces. We're gonna introduce some new faces. It's going to be a real blast. And of course, throughout this, we hopefully all get to learn a little bit about Kotlin, maybe about ourselves. I don't know, about our own problem-solving skills. Thank you, by the way, to everyone who's already said hello. Appreciate all of you. Some familiar faces, some new faces here as well. As a small logistical side note, if you're joining us, you might be joining us on one of two platforms. We are streaming both on Twitch and on YouTube this year, on the Twitch JetBrains channel and on the YouTube Kotlin channel. But we can see your chats nonetheless wherever you are. So wherever you are, welcome. Yeah. And of course, we also have a whole bunch of goodies prepared that hopefully make it very exciting for you to engage with Kotlin in all kinds of ways. First and foremost, of course, with the Advent of Code challenges themselves. But we also want to show off a couple of things and give you a couple of goodies throughout the streams that kind of go beyond this. I'm keeping it deliberately vague right now so that the surprise maybe becomes a little nicer when these things actually roll out. So if you don't want to miss any of those kind of streams, which I would very much recommend, make sure that you enable the notifications for our streams. I mean, and this is also just a wonderful segue for me here to throw my screen up here. So as you can see, we already have the stream scheduled. We're here right now. We are live. And for all the other ones, if you just want to hit that notify me button, you'll get a notification when we're live. And that means you also won't miss any kind of streams that may be happening at a slightly different time. For example, day 7, which is happening a little bit earlier. All the other streams, at least for now, are all scheduled for the same time slot that we are in now. Hello to all the people who are saying hi from the Twitch side. Hello to the people who are saying hi from YouTube. Okay, let's get a little bit of housekeeping out of the way, because of course we want you to write some Kotlin code as well throughout this entire thing, right? It's nice that you're tuning in and you're watching, but of course the ideal scenario is you sit down, you try to solve the problems yourself, and then you come here, you discuss, you compare. So just like in the previous years, we have our wonderful little pitch here, which is solve some Advent of Code 2024 puzzles in Kotlin and win some prizes. I'm going to also post that link into the chat here just so that you can get all the information, but we'll briefly walk through what will be going on. Of course, we'll have streams, we have our wonderful community on Slack, and so on. First and foremost, you can win some prizes, which is quite exciting. So we can just kind of scroll to this. If you've done this previously, you might already know about this, but we have leaderboards for the Advent of Code in Kotlin challenge. We have these 7 leaderboards here. So if you are on Advent of Code, you can click on leaderboard and then private leaderboard. You copy one of the leaderboards here into the join code. You can join it, and then you will appear in that specific leaderboard. We have 7 of them. Please only add yourself to one leaderboard, so that there's space for everybody. The leaderboards are for people who want to compete in like solving these challenges rather quickly. But you don't have to be quick, or at least in my time zone, get up at 6 a.m. To solve the puzzles in order to get some prizes. If you can solve them entirely on your own time and frequency as well, and that's why, or for that specifically, we have a GitHub topic. So here's what you do. You have all the information on this as well. If we scroll down a little bit on how to win prizes, if you solve a couple of the challenges, you don't have to solve all of them, because we all know that, especially as like the holidays roll around more closely, you'll probably have some other things to do as well. But as long as you upload a couple of your Kotlin solutions into a GitHub repository and you add the topic AOC 2024 in Kotlin to it, you can do that by heading over to your repository and hitting this little gear icon. Then you will be added to the pool of people that we will be drawing some lucky winners from. We have some exclusive swag that there is absolutely no other way of getting besides, being in Advent of Code. So it's probably quite exciting. The other part that's important to note here, of course, is that we do have a way of contacting you. So make sure that is somehow available in your profile. I am already quite excited to see, if I'm clicking on this, that there is already 368 repositories that are doing Advent of Code 2024 in Kotlin. So make sure you add this tag to your repository as well. One of the other cool things that we can actually dive into right here, I don't think I've missed anything, is that we also have a template. So if you want to kind of have a slightly opinionated start on how to structure your projects, Jakob from our team has prepared this Advent of Code template that has a specific workflow. So where you can put some specific files. It has an opinionated approach on where you put your inputs and so on. So if that's interesting to you, check that out. That's linked as well. Right. If you want to engage with the community like you are doing right now, everything besides this is also happening on the Kotlin Lang Slack chat. There's an Advent of Code channel there. So make sure you head on over there, and you have people discussing solutions and exchanging information here. But you also have people just posting interesting information overall. Like, for example, Roman here posted a clip of somebody who built a Kotlin notebooks solution to one of the previous year's challenges, and it really shows off like how you can use the different parts of Kotlin and different approaches in Kotlin to solve things. Okay, cool. We are almost ready, and I'm very excited to introduce my guest in just a little bit. But let me just quickly see if I've missed anything here in our chat. First of all, what an absolutely lovely message. I love Kotlin. Trying to get my university to switch our object-oriented class from Java to Kotlin. Wishing you best of luck. There's actually a lot of universities already out there that do this. So there's definitely already some nice precedent on this. Yeah, thank you so much for checking in here. So the first goodie that we have for the Advent of Code streams is, you might be aware of a little event called KotlinConf 2025. Which, I would argue is the place to be if you are interested in everything that's going on in Kotlin. Now, if you're someone who may be a little bit on the procrastinatory side, and but you would still like to submit a talk to KotlinConf 2025, even though the call for papers or the call for proposals was supposed to close yesterday, we actually opened it for another 7 days. So if you are someone who has something cool to share with the wider Kotlin community, make sure you submit your proposal to the KotlinConf 2025 call for proposals. If you are accepted with a full session, we cover the travel and accommodation as well. So it's a very cool way to get into KotlinConf and share some of your knowledge at the same time. I also want to mention that there are still some tickets left for some of the workshops that are going on at KotlinConf. We have a couple of these, and the instructors are a whole diverse group of people with different backgrounds. You have JetBrainers here, you have external folks, and whether you want to learn about web development or backend subjects, or if you want to learn about, for example, Kotlin coroutines, we have sessions for those everywhere. And this is also what I am going to use as my somewhat natural segue to introduce my first guest of the Advent of Code 2024 campaign. Because who we have on today is none other than Seva Tolstapyatov, who's also helping me out on giving the Kotlin coroutines workshop. Hey, Seva, welcome to the show.
Hey, nice to see you. How are you doing?
It's very nice to see you too. How are you feeling? Are you already slightly in the Advent spirit?
I'm trying to get into that. It's my first ordeal with Advent of Code. Previously, I was not doing that because plenty of other teams, members of our team, were doing that, and I was quite reluctant. But right now, I'm excited to see how ergonomic Kotlin is, where we have some sharp edges, and maybe we can patch them up, and how it's going in general. So yeah, I'll try. Yeah, go ahead.
Yeah, I think this is it's one of my favorite parts of of doing Advent of Code is it typically does spawn a discussion in the related Slack channels about people noticing that maybe there's something missing in the standard library, or maybe some behavior isn't quite as you would expect it, or sometimes we even end up discovering problems in the type inference algorithm, like we did last year when we realized that sum off doesn't do that well if you're if the expression you have attached to it is just a constant integer, like all kinds of things. And I already this morning at like 7 a.m. I did receive a UTrack notification from one of our recurring guests who noticed an issue in the K2 IntelliJ plugin that affected some of the sorting, and he complained about the fact that it cost him a couple of seconds on the leaderboards, which which I can somewhat understand. Yeah, so I think you also have a bunch of exciting things with you, and of course, I think you are in a very unique position to talk about Kotlin and the standard library and all this kind of stuff. Do you actually want to maybe just briefly give us a short introduction of what your relationship to Kotlin is, what you've been doing?
So originally, I came to Kotlin as a co-maintainer of Kotlin coroutines, and I basically touch everything that exists there, or to some extent invented or contributed to. And then I began to jump on more and more responsibilities. And right now, I'm in some weird position called core ecosystem lead, which basically is all the teams that are developing Kotlin libraries and all the tooling around, like build tools, KGP, Kotlin Gradle plugin, Docker, and everything around it. And sometimes we influence language design and how our tooling and IDEA and fleet behave in regards to Kotlin.
Very cool. That's awesome. Yeah, so if you have any questions that you feel would be maybe that Seva is the correct person to answer those, feel free to also add those in the chat. And if we have a little bit of time at the end or somewhere in between, we'll also make sure we get to those. Okay, well, we did have a coding challenge that unlocked a little while ago. So as is tradition, I am going to put on my wonderful little reading hat here, and I will be doing what most people don't do when they first solve these challenges, which is actually read all the fluff text that surrounds. There we go. That surrounds the overall story. And look at this, we got lucky with the RNG on the sponsors. We got the Kotlin by JetBrains sidebar on here as well, because of course we are sponsoring Advent of Code this year again as well. We are super excited to be one of the sponsors and support a great project like this that allows people to engage with programming in such a fun and playful manner every year. Okay, so with all that out of the way, it is time for day one, Historian Hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. They figure the chief historian must be in one of the first 50 places they'll look. So in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck! You haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. It seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search? Throughout the chief's office, the historically significant locations are listed not by a name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into 2 groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the 2 lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. For example, 34, 43, 25, 13, 39, 33. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, and then the second smallest left number with the second smallest right number, and so on. Within each pair, figure out how far apart the 2 numbers are. You'll need to add up all of those distances. For example, if you pair up a 3 from the left list with a 7 from the right list, the distance apart is 4. If you pair up a 9 with a 3, the distance apart is 6. In the example above, the distances are as follows. I'm going to go through a couple of these. The smallest number on the left list is 1, and then the smallest number on the right list is 3, which makes the distance between them 2. The second smallest number on the left is 2, then the second smallest number on the right is another 3, which makes the distance between them 1, and so on. To find the total distance between the left list and the right list, add up the distances between all of the pairs you found. In the example above, this is 2 plus 1 plus 0 plus 1 plus 2 plus 5, a total distance of 11. Your actual left and right lists contain many location IDs. What is the total distance between your lists? And we can just take a super quick peek at our puzzle input, which is a reasonably long list of IDs that we'll need to work through. A little more than I'm comfortable doing like on paper by hand. So, Seba, over to you. What was your first like initial thought when you read this? How much of this did you read? Did you read it bottom up? What was the approach?
I read it bottom up. Yeah, I quickly grasped the idea. I tried to understand how example is computed. I figured out what they want me to do conceptually, and then I jumped right to the code.
Okay, very cool. I feel like, especially for the first couple of days, that's pretty reasonable. I'll be honest with you, starting at like day 8 or 9, sometimes I'll need to whip out the paper and start drawing weird cubes and intersections. But for now, it seems we're fine here. So I'm actually just gonna throw us over to your screen, and I see that you have a terminal open, which is interesting because I figure I guess we're starting a little bit a little further ahead than just starting right into the code, huh?
Yeah, I have to create a project. And right now my go-to build system is Empa because it's more or less lightweight, basically a single file, and really pretty much quick in response. So I don't have to wait for my project to sync up, to download all the dependencies, to figure out some maybe Gradle or Maven peculiarities. So I'm using standalone Empa. So let's create a project. And it suggests what kind of project I may want to create. And it's going to be a command line one. So here it is. Almost there, sorry. Yeah, let's create it. And then let's just open it in IDEA.
That was quick.
Everything that is not interesting to us. And I have a small hint. So we have to read an input. And I already pre-downloaded it, and all I have to do is to read it. So let's write it. And we have to get list of strings in return. And we have to create a path. And let me check. It's somewhere here. Yeah. And I often make a typos here, so let's double check that it works.
Could I ask you to collapse the project window on the left?
Sure.
Thank you.
And it's day 1. Oh. Let's see. Yeah, it works.
Okay. That was fast. Going from like not even having a project to like reading all this. That was pretty smooth.
So what do we have to do? We have basically 2 lists of numbers, left and right. So we have to declare them. And yeah, it's not what we need. It's lines, and we have to do some transformation over them. So let's map our lines. And honestly, I was too lazy counting number of white spaces here. So I'm trying to be as expressive as I want. And the first number is we want to substring our string before the first white space. And we don't really care how many white spaces there are. And we have to transform it to int. And for the second line, for the second number, we want to do the same, but we want to substring after the last white space. So it's basically the same. And standard library also has a nice extension here on string, substring after last. And we have two numbers. And let's return a pair. Now we have a list of pairs from first number, second number, but we want to get two lists of numbers. And we have a standard library function for that, which is called unzip, which does precisely that. It receives a list of pairs and return a pair of lists. Quite convenient. Now we have to compute something. Let me check what we have to we have to compute the distance between those two numbers, right? But we have to match one list with the other. The smallest number in the first list with the smallest number in the second list, the second smallest number in the first list. We basically have to sort them. So let's sort it. And we have to match it. For that, we have zip, because we know that those lists have the same length, the same size. And we zip it with the right sorted as well. And now we have to do something with that. And we have to subtract the largest number, vice versa, the small number from the big number, or we can do very simple, and we can compute the absolute number. And it's going to be even more robust, though I haven't checked the text fully. I don't know whether negative numbers are allowed. But if we are going to have, I don't know, integer mean value somewhere here, and we are not going to use, or somewhere around maximum and minimal values, we are going to have an overlap. And even if we'll compute something like max of two numbers and min of two numbers and try to subtract one from the other, we might get a negative number. And we have to sum up it, right? Do we?
That's right.
Yes. So. Oh. Let's see. Yeah, and it is the right answer because I already submitted it. You have to trust me.
I'll believe you on that. There's a couple of nice comments here already. It seems that this is an approach that we've definitely seen from other folks as well. The approach of first doing an unzip and then just doing a zip again. It seems that there's a couple of people who were just, unzip is already a well-known function to some folks. I'll be honest with you, and when I wrote my very first implementation for this, I just kind of did a manual destructuring of those. We'll take a look at my code a little bit later. But another comment that I really enjoyed here was one from Jakob. Just to int is safe today, but we have learned in Advent of Code before. Just like you said, when you're starting to get to those boundaries, when the numbers start getting big, or when your sums all of a sudden start turning negative. Then most likely it's a good move to go for too long or operate on long values because the numbers after a couple of days do get a little harder.
Yeah, it might be the case. I've just skimmed through the input and it all seemed quite small. So
yeah, this was also kind of my approach on this here. So there's also still I need to take one step back here because I feel like you really browsed through the way that you constructed the project in the first place, which is you just whipped out a CLI client for Amper and just created something in a new project.
So now, Amper has
what's up with that?
Amper has a standalone mode where Amper builds itself and where you don't have to have any dependencies. And you have to download it and install it to your system. And I have my own JetBrains endorsed homebrew package, which basically downloads the Amper and links it to user local bin of homebrew. And with Empa, it has quite nice command line interface. And you can see what version it is, you can build it, you can see what tasks it provides, and it also provides an init script. So you can create any project Empa supports. And this, by the way, about unzip and about Empa, a good design is when you don't have to know about the feature, but you might discover them. For example, if we'll take a look at our code, and imagine you don't know about unzip. What you can do is you can just skim through all the extensions and something, for example, zip, and and there will be unzip. And you can figure out how, hey, unzip looks similar to what I need. And you don't have to know about it. You can discover it. The same goes with Empa. You can try Empa init, and you don't know what you need, what you might want to. And Empa gives you a hint. I don't know what you want to, so here's options. And I've picked JVM CLI because we need a command line, simple command line, one file project.
Yeah, I mean, this is really a really smooth way to get started. Can you maybe open up briefly the actual build file that it generates so that we can see what it puts in there?
Sure. Let's fix it back. That's basically it.
That never gets old for me. I'll be honest with you. So, and I also see that it has, so as I understand it, Amper has two modes, right? Like we either have a Gradle based mode, which is for compatibility and so on. But I see here that there's not a single Gradle file in your project right now. There's also no Gradle wrapper, and instead there's an Amper wrapper. Do I see that right?
Yeah, there's an Amper wrapper, which is not a wrapper over something else. That's a standalone binary, and it's not even a binary. It's a shell script that downloads the binary and puts it somewhere in your cache, like in home directory.emp or something like that. We probably can check. Yeah, it has something here.
Okay.
No, only Kotlin specifics.
All right. Okay. But it means that in this scenario, you're completely standalone. Could you run the same app also, your app that you just built from the command line as well using this?
I think so. I never tried, to be honest. Let's see. Empa build. Oh, it has Empa run. Yeah.
That's standard out. Okay, look at that. Wow, this is super cool. So I think in our shared notes document there are some instructions on how to do this. So if people are interested, I'm also going to be sharing the link to your homebrew tab, and I'll actually, when we switch back to my screen, I'll actually walk through this installation because this seems very smooth.
I hope it works.
Elegant. Yeah. Let's briefly head on over to the to your solution again for a second and see if there's anything else that's maybe worth pointing out in Kotlin. I mean, I feel like there's not. I can't really give you any compliments again because you've kind of had you're a lot closer to the standard library than I ever was. But I mean, very good use of all the functionality that's in the standard library here. I feel like this is very idiomatic. It shows that there's a lot of things that just kind of click together very nicely. Like the fact that you can specify, from starting from your very first line, right? Like you can specify your functions in Kotlin with an expression body rather than having to have a block with a return statement inside. The fact that we have this destructuring syntax, and this combines back with this infix to syntax, right? So you can create pairs really quickly, and then you can break the pairs up into their individual parts of left and right again so quickly. And then, of course, the fact that, for breaking apart a string, you can just kind of guess that it's hey, I'd like the substring before, and then the function just exists. And I mean, I wouldn't have. I'll be honest with you. If you had asked me from the top of my head whether substring after last existed in the standard library, I mean, I probably would have just said yes, because there seems to be a pattern of like when I need it's just there. But it's always very comforting to have these things. Yeah,
you can discover it. You know that you need something, substring something, and you can see all the things that exist here that's similar to substring.
And that's exactly also kind of the beauty here, right?
What the biggest beauty here, and I think one of the Kotlin standard library strengths is that it's not about code goal. It's not about how many functions I should declare or how many code I should write, because probably like, if I really stretch my skills, I can, I don't know, make it twice as small, probably. I don't know. But the key here is ergonomics, that I explain to you in words what I write in code. It's like I explain my intent clearly, and the code and the standard library or the functionality that exists there reflects clearly on the intent.
Yeah.
So I don't know, for example, about number of white spaces, and here I just substring it. I don't try to loop over it manually and write a comment that it does this, it does this. I just explain what I want to do. It's more on a declarative side than anything else.
Yeah. I think the only parts that probably need like if you just come from a different background, I feel like zip and unzip are, as well as like map, are maybe like a little bit foreign as like just from the terminology, but those are the things where like they're established terms, don't get me wrong, but they might just not be something that you've encountered before. So here, like the real value is really kind of like leaning into the functional approach, right, and a little bit like this functional world of transformations.
Come again, sorry.
So that's all good. Like if you're, I think for a lot of folks, when you're first starting out with Kotlin and you come from a background maybe from a more imperative language, like there's a couple of like there's some vocabulary that you probably need to know to really make the most of things. Like map, as in just like transforming each element, and then I think zip and unzip are the ones that are slightly mind-bending to people, because it turns like one thing into multiple or multiple things into one thing.
Yeah, I kind of, over the years, I got used to that, and it's just somewhere in my muscle memory. So if you want me to explain something, just ask and I'll jump on that.
I have a feeling that maybe we'll see something about that in part 2. But if you folks, if you're in the chat and you are interested in like diving deeper into any of the specific lines, we'll happily like break it down even more. Until we do that, however, we got a right solution, right? So with that, we are eligible to actually move on to the second part. Also, just as a quick note before we do this here, there's a couple of points that were made by folks. Like one of the sorry, let me do it the right way around. Like one of the big advantages of Kotlin is also that, you know, even if you don't know yet what all the idiomatic things are, you can still write Kotlin like Java and still get a working solution pretty quickly. But then step by step, you can you learn what's idiomatic, you learn what's in the standard library, you discover things by just hitting the dot key and scrolling for a little bit, or just typing like the prefix of what you like. And then you actually grow your skills, which is one of those things that really allows you to learn these things step by step and adopt them at your own pace at that. Okay, great. So with that, we're going to switch back over. Great job on that solution. I don't think I'll spoil too much here if I say that my solution looked pretty similar, and of course we'll take a look at that in a little bit as well. But first, we need to complete the second part so that we get a gold star and not just our little silver star. So we are ready for part 2. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting, but in the commotion you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that the number appears in the right list. So, with the same example list again, for these example lists, the process of finding the similarity score now goes as follows. The first number on the left list is 3. It appears in the right list 3 times, 1, 2, and 3. So the similarity score increases by 3 times 3 equals 9. The second number in the list is 4, which appears in the right list just once, just up here, which means the similarity score increases by 4 times 1 equals 4. The third number is 2. Now we can do this without even trying to read it. It doesn't appear any time, so it should be 2 times 0. So the similarity score does indeed not increase, and so on. What is worth noting here actually is that, of course, now we are seeing the fifth number 3, which once again appears 3 times. We already checked this earlier. And then we have 3 again, which once again appears 3 times. So those are 9 each. So, for these example lists, the similarity score at the end is 31, which is 9 plus 4, 2 times 0, and 2 times 9. Okay. All right, small change. Siava, when you got to the second part, did you feel like you had parsed the data in a way that made this easy? Did you feel like you painted yourself into a corner? Any other thoughts?
No, it was just one more straightforward task to do. And
all right, fair enough. So, yeah.
But let's try to do it in a slightly different manner. Let's try to make it a little bit more code golfing. So we have to read our lines anyway. It's not something that we can avoid, and we still probably need, if we're not going fully functional, 2 lists that we'll later do something with them. But let's use something more concise, or not concise, a little bit more short, but maybe less approachable. So we have a line, and we know it's 2 numbers, so we can, and some number of white spaces, so we can split it. But 1 white space is not enough, so we can use regex, as we know. Oh, thank you. As we know that they're easy to get right and quite understandable. But here, the split returns array. We're now going to read that, and we want to have 2 numbers. So let's use let function. That will return that's a pair of first element and second element, and we want 2 numbers. So we're going to use toInt, or we're going to use toLong, as it was recommended. And also, we want this program to be correct, and we don't know whether we have a bug in regular expression. So we're going to use require the list size is equal to. The list size is 2. And we unzip it. It's much less readable. It's just a different approach to do things. But if we'll get rid of sanitization, it's basically a one-liner. I'll put this. And we again have our left and right arrays. And we have to compute frequencies. And for that, For that, we have a handy functions in the standard library. We have grouping by, which, yeah, perfect. I'm not sure if it's AI assistant or a regular assistant, but it did what I wanted to write, which is a really nice thing. So grouping by creates an intermediate collection-like thing that accumulates values by its keys. And our key is the value itself, the number, in some manner. For example, we can compute some statistics. And the number of elements is one of the most common functionality that people use. So we have a shortcut for that in the standard library. Alternatively, we could have written something like group by it, which returns a map of type. Returns a map of type from long to list of longs, and then we could have mapped values into its size. Yeah. And it is the same type, so we can specify it here as well. This option is a little bit more efficient because here we create an intermediate map, and then we map it again. So we have our frequencies, and now we have to compute something which is, let me check, it's similarity score, right? Yeah, similarity score. So we have our left numbers, and we can iterate over them. And similarity score is number frequency. Thank you, IntelliJ IDEA. It's faster than I am. So we can just ask the frequencies of the number. But the problem is, it might be missing. It might be absent. There might be no such element in the map because in the right column, there were no such number. So we are using get_default and using 0. And here we create a similarity score for each of the number in the left column. But we want to sum them up, right? Do we?
At the end, we want to sum them up.
Yeah, we can use map and sum, like in the previous solution, or we can be a little bit more functional if you put it that way, or just use a different combinator. We can use a fold, which accepts an initial value, which is 0, and then we go over each element of the collection, and we invoke lambda, which accepts accumulator, what we passed here, and the element, and we compute something that is going to be the next accumulator. So basically, we are doing accumulator plus type, yeah, this way, and we let's also print it. Yeah, here it is. Hopefully it works. And let me check. And that's a right answer again. And you're going to have to trust me here as well.
Okay. Okay. Yeah, I feel like we have a lot to talk about here.
Sure.
So okay. Well, first of all, let's break it down a little bit. I mean, the overall structure here, it's still fairly similar. The parts where it might start to get a little bit tricky is when we look at line 11. Okay, so first of all, very neat that Kotlin has the option to do split on a regex. Is there a difference, or is there a reason why here you've preferred the regex kind of like constructor call over using like .toRegex on just a string?
No, just a matter of style here. Yes.
Okay.
It's correct that you can use something like to regex. Yeah, to regex.
Yes, because what my
It's
favorite
basically
part
the
about this part is that you can also use raw strings. You can use triple quoted strings, which means you get rid of one escape sequence typically, or you sometimes get rid of escape sequences.
Oh, and here we actually, no, we don't have a bug here. Yeah, plus is supposed to be here. Yeah, you can use triple quotes, and then you don't have to write. You don't have to use a escape sequence.
Which always I think makes it a little bit neater. And I think the other quite cool part is that if you hit Alt Enter on this, I believe there should be a regex checker that should just be available under check regex.
Yeah.
Which is also awesome, because now we can like just type two things, and I think it'll show us it'll show us what matches the that regular expression. So that's good for doing a quick little check.
I've never seen this one before.
Hey, look at that. See, we're all learning new things here.
What I really like is that IntelliJ IDEA here knows that this is a regex, the regular expression syntax, and it highlights it in a very specific way. So probably if I'll do something like that, yeah, it highlights it in a proper manner, which I really like.
This is actually one of my favorite features in IntelliJ in general, because these language injections are like actually they are available for a bunch of different languages. So if you're editing, if you have a string that just happens to include some JavaScript or some HTML, you can just hit Alt Enter on that, and you can just say inject language. Like JavaScript, and it will automatically add like some syntax highlighting for this specific block, which is quite awesome. For me, I really like this whenever I work with like JSON literals. In like JSON literals, I just do that very quickly, and that's very smooth. There's one question here, which is what's the difference between to regex and to pattern? To regex return a regular expression, which is our own Kotlin specific class, and it's slightly different from a Java util pattern. And to pattern returns a Java pattern. Yeah, it returns a class from the Java standard library, Java util regex pattern. Do you have a recommendation for people of which one to use if they don't have any specific requirements? Use regex because it's native to Kotlin. That's where we try to provide the very best experience, the appropriate extensions, appropriate functions, and pattern is more or less a second-class citizen because we don't have a direct control over them. And for example, there might be things that we don't want to see in regular expression engine. So it also means that I guess if to regex is part of the Kotlin standard library, that also makes it multi-platform, right? So if we're doing something on other platforms, and it's really painful. I have to complain about that because regular expressions, like my favorite fact about regular expressions on Java platform, regular expressions on Java platform do not describe a regular language. They describe a non-regular language, a more expressive thing. And every dialect of regular expression slightly diverges from the standard. So it's hard to get something in the multi-platform that behaves in the same way on every platform. And if you're really tricky and really crafty, you can break it probably. Okay, that sounds a little painful, and I guess that's a fun little challenge. If you manage to break the regular expressions, I guess let us know in the chat or in the Advent of Code channel, and we might just feature you. So okay, we're only like 3 lines into this, and there's already plenty of things that we want to discuss. There was one question here from a snippet that briefly appeared and then disappeared, which was, can you talk a little bit about require? Sure. Where we are here. Yep. So require is basically a precondition. It accepts some invariant Boolean, like we want to know that size of our list is 2. So we require it to be 2. And we can
we can provide a lazily evaluated message that if this invariant is broken, like for example, we can set it's 3 and run the code, this code will throw an exception, illegal argument exception, that the line contains more than, it's something, line contains not what we expected to. You see how I get used to this full line completion, and I, from time to time, I completely ignore what it completed with, because it seems correct.
That's dangerous.
Indeed. And require is something that we check, something that we use for inputs, for parameters, for arguments, and it throws a very specific illegal argument exception because you check it beforehand. It's a precondition. And for invariant assertions, you can use check. We have a check function that has the very same signature, but it throws illegal state exception. So after some computations in your program, when you process user input, you want to ensure that everything is correct, you use check. If you want to sanitize user input, you use require.
Okay, so require goes in the beginning for the preconditions, and then check is for just more general invariants, I suppose.
Right.
It's also maybe interesting noting here that the lambda parameter or the message part is part of a lambda rather than just being like an additional parameter. And I guess the reason for this is that, you know, the path that you hit for your message is not hit that often, and might do some kind of like diagnostic work that you don't want to eagerly evaluate on each loop. Is that the main motivation?
Yes, you basically, for your preconditions, you are more or less expecting they always to be true. You don't want them to break. And for the diagnostic message, this message is, honestly, I would expect IntelliJ IDEA to highlight it with the yellow code because it does not contain any context in it. So for example, if you have your production system web service and it crashes with illegal argument exception, you at least want to know what argument is. So you want to add it to the string. And even better, you can use interpolation here, which is basically the same. And this one is quite costly because you want to append arbitrary size list, because we don't know which size it is right now, when this assertion breaks, to the string and allocate. And we want to do it lazily because we know that most of the time this assumption holds and it never should be computed eagerly. So that's why it's lambda.
Very nice. Another part that's probably worth mentioning is that require and check, the conditions that they have, they also work with smartcasts. So if you assert inside a require or inside a check that a value is non-null, then in the lines below that, the compiler knows this and will actually treat everything below that line as, okay, now the value is non-nullable, which is quite elegant.
We don't have sources here, but it's not the compiler knowledge. And in general, in the Kotlin standard library, we maybe have 1 or 2 places, and which we regret about, that depend on that are tied to the Kotlin compiler. In general, you can write everything that exists in the standard library as an extension library on your own, and it is going to work in the very same way. So what makes this magic work, where you can require something is not null and then use it as a non-nullable type, is a Kotlin language feature contracts, where you can say, hey, if this function returned, then the type you have is non-nullable, or this statement is true. Yeah.
Just going to throw that up here. So it's this contract where it says returns implies value. And that's enough for non-nullability?
Yes, it's the same as you wrote it without a check value. So if you'll write value equal null and then some braces, then you would expect compiler to infer that the type is non-nullable. And here it's basically the same. If it returns, then we are sure that value is true.
Okay.
So implies value, it's like Boolean value.
Mm-hmm. Which is our expression, and then if that expression happens to be a type check, then of course we can that constraint can be propagated forward. That makes a lot of sense to me.
If you'll jump back to my screen,
of course,
it basically means that check some expression like who is int or it is int, which is definitely not the case. Its contract there says that if the function returns implies value, it's in the same context as if it is int. So it implies that value is true. So we can use it here as an int. And probably here, yeah, we can use it to long to each. But this code will never be reached because idea tells us use this check here.
Okay, so if you move that statement up by one line, sorry, just for a second, then it should still be fine because it's the same
because we have check. Yeah, yes. And now it doesn't work. Yeah.
Okay. Yeah. So it actually does introduce one extra, like the extra constraint, or that's very cool.
And it's funny how here idea complains that this check is always true, and it says so because this check is. It complains here that check is always false. But if we reach here with some magic, or I don't know, compiler bug, then this condition will always be true because we already checked that.
Yeah, that makes a lot of sense. That's just that's propagated forwards. One of the questions we have is contracts are great, but when are they going to stop being experimental? Care to comment?
When they're ready. The
okay.
answer is when they're ready, because there are some sharp edges that we want to polish, and some of them are conceptual, and some of them are syntactic. For example, right now with the current contract syntax, you cannot put a contract on interface method, or you cannot propagate it. For example, if you'll write something like, let's say, left as list any question mark, and if you'll use filter it not equal to null, this is not, there is no such contract that will propagate further and will allow using it as non-nullable type. And whether it's solvable or not, we are not sure, but we would very much like to try.
Okay, gotcha.
The same goes, for example, with it, I don't know, is int. It also would have been handy to be able to write this filter, then use this expression as a list of integers.
So for now, we're still stuck using filter as instance and filter not null?
Yes, correct. You have to write something like that.
So you can still express it, but it would have been nicer if a primitive would have just allowed this to work out of the box.
Right. It's basically a workaround around our lack of specific capabilities in the type system.
Yeah. And then we also had one more good point. Okay. Next line. Grouping by each count. Very, very neat. Gives us exactly what we want, which is the frequencies inside of our list. But it requires us to first do like a grouping with, I guess, a key that just happens to be the identity. Is there a reason why we don't just have like a .counts, or something like that in the standard library?
What do you mean by .count? Like you would like to write something
essentially
like that?
Yeah, pretty much.
Because in general experience, when you have a collection of something, it's not a string and it's not a number. It's some domain-specific class or data object or something like that, and you have some part of this object to be the key. For example, ID from the database or person name or something like that. And for that, you, like in 99% of the cases, you have to have a key selector. You have to be able to tell the standard library what the key is. So this function would have been handy in competitive programming and in advent of code, but in a general enterprise development, it would have been very much useless.
Okay. And then, of course, here's a good question. This might just, of course, be that you wanted to flex some of the functional muscles again a little bit. But I think there's a nicer function in the Kotlin standard library called SumOff, which was also shouted out, that also takes a lambda that I think can replace your fold here, right?
I think so. Yeah, that's a nice observation. That's our answer. Let's write it down. And we want to sum off. And we should have the same answer. Yeah, it's the same answer. Yeah.
Yeah, look at that. Okay, cool. So hey, thank you very much for that contribution. Really appreciate that as well from chat over here. But yeah, okay. This solution is definitely a little more compact. Certainly goes a little deeper into I guess maybe also what one could do if one wanted to. I'm actually gonna just steal the screen here again, and I'll kind of walk you through what I did first, then maybe how I refactored it a little bit, and then I got a tiny little bonus in the end. This is always my favorite part because I do try to compete in our internal leaderboards every once in a while, which means my code looks like absolute garbage when I write it for the first time. Also, a little note here is that since I compete in the leaderboards, I have the AI completions and full line completions turned off. And of course, we hope that anybody else who is competing also follows that code of ethics. If you're going for a leaderboard position, just write the code by hand, please. But yeah, a couple of things are still similar. One of the things that I was hoping for in your code was the fact that if you call string.split, that actually also gives you something where you can just do a destructuring, which is super exciting. So you can, if you have the two numbers from the left column and the right column, you can just destructure those right away and then turn them back into the related pair. The rest of my code, I think, is relatively similar. In the heat of the moment, I did not realize that we had an unzip function. So essentially, I just said, okay, for each element in my map, which is just the two lists, I first grab myself the first element and then I sort it. So this is for part one, and then the second element, and I sort it as well. And then I just pair those back up. We do the same kind of mapping. I take a look at those distances, and then for the second part, because again, I'm trying to reuse as much of my code as possible. I don't really care about whether I can even check it into Git. I'm like, I just continue writing. So I'll go back to this list of two columns, and I'll just do the sum off between the first element that we have. So each left element, and then the number of occurrences. And immediately when I wrote this, I was like, the performance of this is not gonna be great, because like we saw in the example, you might oftentimes hit like duplicates, right? You have like a 3, and then in my case, for this 3, I'll go through the entire list, and then for each other 3, I'll also still go through the entire list. In your solution, Seva, you obviously already had your like frequency map, and that would have probably been my next step if this had been too slow. But thankfully, it wasn't. Then, you write, you submit, you have a coffee, you reconsider, you rewrite it a little bit. So this is a solution that I feel a little bit more comfortable actually presenting. Where I kind of try to split out the part of the side-by-side list parsing as nicely as possible, which is really just now has like a slightly nicer name, and it only takes care of the actual casting. It doesn't take care of any kind of sorting or the like. This, by the way, is also maybe an interesting note here. This only kind of happens this only works incidentally, because I already do this work on the sorted lists. Like I already made a permutation or a change on the list. It's just lucky that, you know, summing things, it doesn't really matter which order you sum them in. But when the operations become more complex, you probably don't want to have such a dependency built in. And then I just extracted two functions called part1 and part2 that get those unzipped columns. For part1, you grab yourself the sorted column pairs, which is you grab the first one, you sort it, and you zip it to the second one sorted. So you just kind of, again, the typical thing is like a zipper on a jacket, like each element just gets correlated together. And then I just use sum off to calculate the actual value, which, just like in your case, is the absolute and then the difference, or the subtraction. And for the second part, again, like this solution is just as it's the exact same solution I just mentioned. So I just use count, which allows me to provide a selector, and it will count each element that has this Boolean condition true. So effectively, I'm just seeing whether that first column item does appear in that second column, and how often. And then, yes, I have the same implementation like yours. I was looking for a second. I know, like, it's already burned into my brain, this kind of syntax of grouping by each count and then like working a little bit afterwards, trying to figure out what my selector would be. Oftentimes in Advent of Code, it is just the identity. It's just like an it. Yeah, and then you just do a sum off. I did this slightly differently. I think you did get or default. I used the indexed access operator, which if you just write that out like naturally, you'll get a compile error because, well, this gives you an integer question mark, so a nullable one. And like the two ways of how you might approach this, you can either do get value, which in this case, because you might not necessarily find something in the second list, this is just going to crash with an exception. Or the slightly more reasonable way of doing this is providing a default value. In this case, it's kind of like our count. Because this expression now has like a multiplying and an Elvis operator, it does ask us to add some parentheses before it like actually lets me compile. But that's it. I don't think there's anything particularly special in here. Seba, any comments?
No, I don't think I have any additional comments here.
Okay, then let me throw you over to another thing here, because I figured we might as well keep it a little bit interesting, because now that I have two solutions, one that does this weird .count in each iteration, and then I have another one that just like yours creates this map initially, which is the frequency. I wondered what the performance might look like, and for that, my mind automatically goes to a little library called KotlinX Benchmark, which is our multi-platform benchmarking toolkit, but multi-platform also includes the JVM. So since I happen to write for the JVM, I just decided to set this up. And there's a couple of examples. There's a setting up Kotlin JVM and Java projects for benchmarking, which is really just a couple of steps. It's adding a plugin, making sure that you have the plugin portal set up, adding one runtime dependency, and making sure that you apply the all open plugin, as well as registering things. Once you've done that, you can start writing benchmarks. I wrote a naive benchmark. I can run it, and I can give a little bit of an explanation of what I tried to do. But since you are uniquely positioned in the way that you've probably touched a lot of the ecosystem, I would also be very curious to see if what I built here even is a reasonable benchmark. So we'll walk through it, the general structure.
Yeah, let's take a look.
Let's first of all try to find out what I just broke. Did I break something? Did I remove the input? Index out of bound exception.
So it's somewhere in the initialization here, right here.
Okay, that's a little odd. This is input day1.txt. I swear I ran this like half an hour ago and it worked. Ah! Let me just check if I broke it for good. I did break it for good. That's a little uncomfortable. Okay. But I guess there's nothing more fun than doing some live debugging.
You can right-click on the input and yeah.
Oh, the input only has one column. Yeah, I overrode my input. Thank you very much. Thank you, everybody. I appreciate it. I got so locked into trying to figure out what's wrong. Appreciate it. I like Maya. Appreciate you also mentioning that I should check the Git history, but actually, ironically, the inputs are the one thing you're not supposed to check into the history. So that's the one thing I couldn't have checked. Okay, now it's running. Great. This was just me testing something else. Classic. Okay, so we can run this and it'll do some warm up and some operations. But yeah, so overall structure. I have a benchmark. I try to set up some things like outside of the actual benchmark functions. That is like reading the actual text, because I don't want to benchmark my IO. So this is the same like algorithm I used in the individual parts. Since I get this side-by-side list, I need to do an unzip, which, as maybe some other folks have also noticed, is something I can't do just as part of a class variable, so I have to do it in an init block. And then, in my naive approach, I just benchmarked the normal version and the one based on the map, just by calling them with the same parameters, and then crossing my fingers that the benchmark that would run would actually give me somewhat reasonable results. And I guess we'll wait for this benchmark to complete. But in the meantime, is this a reasonable way of approaching a benchmark?
So one thing that caught my eye is that you are not using the result of part 2 and part 2 map, and it's quite an important one. We might want to change that and see if it affects the result. So the Java compiler, the JVM runtime compiler, just-in-time compiler, it compiles the code on the fly. So on the fly, the compiler is able to figure out maybe some invariance always being true or always being false, or some values not being used, and it is able to optimize it away. And not only the value, but the whole computation. So for example, if you'll try to compile this code with, let's say, GraalVM, which is a little bit more advanced compiler, because it is able to compile everything beforehand and spend as much time as it wants to, it might take a look at part 2, into part 2. Could you please navigate there?
Sure.
Yeah, so here you compute some result which has no side effects. So you don't print anything in the output, you don't really allocate anything here, so there's no possibility for out-of-memory exceptions. It's just two plain old for loops and a counter. And then you return its result to a benchmark function, but you don't use it. And the compiler is able to figure out that you don't need the result, so it can start optimizing some parts away. For example, at first it might figure you don't need a sum, so it can eliminate addition completely. And then it might notice that you don't have to iterate over the second thing and optimize it away, and iterate over the first thing and optimize it away. And in the worst case, it will be an empty function, and you'll be benchmarking an empty function. So what you can do here is just to return part 2 result from the benchmark function. Or you can use a black hole, but it's a little bit more complex approach.
So here I can just do return, and I guess it means that it's okay for these functions to also return something. Okay.
Yeah, and benchmark infrastructure will figure it out.
Okay.
On JVM, we are leveraging and basically reusing all the infrastructure of JMH, which is maintained and developed by JVM developers. So we can be more or less sure that the results are not optimized away. And on Kotlin Native, we are using the implementation provided by Kotlin Native runtime developers. So there we also can be sure that it's not optimized away. And on JavaScript, it's not optimized away.
Okay, gotcha. Yeah, this is, I think, something that's very important for a lot of us to learn here. It's Jakob also agrees here, whether that's a valid point. An interesting question is, could you just like check, like, or I'm not sure if this is a question to me or if this is a question about the JMH, like, if can I just do an arbitrary like if check after I call the function, and that will also prevent it? Or if that if check doesn't have a side effect, the JVM might also just start like fixing or removing parts from my actual benchmark function?
The best thing to do with benchmarks is not to speculate, because you might be right this time, but wrong the next time, and you'll never notice. So with a specific check example, it depends on the compiler. If it is able to figure out that the function is pure, it depends only on its inputs, and inputs never change, then it might notice that for the very same input, it always returns the same results, and there are no other inputs. So it might be the case. It's unlikely to be that way on the JVM and with C2, with a built-in C2 just-in-time compiler, but it might be. So better not to do that.
All right. So we have a first result for the benchmarks, which might be also heavily skewed by the fact that, you know, there's a streaming software going on and like all other kinds of things. But at the very least, we noticed that the throughput on benchmark map, so this is the one again where we didn't actually use the value that we got back. The throughput of a benchmark map is like 41,000 operations roughly, and the normal one, or the one with just doing count within the loop, only has like 1,500. Yeah, that's a pretty significant difference, I gotta say. So I guess I'm not sure if we can already call this dynamic programming, since there's not a lot of recursion going on, but certainly putting things in a map and then looking it up is a lot faster than just iterating a hugely long map. Yeah.
I think that what we can improve in our benchmark infrastructure, and actually we have to reuse the JMH experience. If you'll run a JMH benchmark, and I happen to have one, but it's quite slow, so maybe we have to. If you'll switch to my screen, I'll showcase it to you.
Of course.
So I have some.
I don't think you have your screen shared right now.
Come again?
I think your screen is not shared right now. I think you have to re-enable the screen share. There we go.
So I have, some benchmarks. Let's ignore what it is.
Could I ask you to zoom in just a little bit?
Yeah, sure.
Thank you. That's great.
Yeah. So if we'll run a pure JMH benchmark, for some reason my when I stream the screen, and sometimes lags, so it's quite slow. It measures something. It doesn't matter. What matters is what will be showcased after the benchmark.
I already can't wait. I'm excited. Yeah, I mean, I'll be honest with you. Most of the time, I end up only benchmarking my Advent of Code solutions. It does not come up in my day-to-day so regularly. Okay, sorry.
So here's the key takeaway from any benchmark. Let's read it out loud. Remember, the numbers below are just data. To gain reusable insights, you need to follow up on why the numbers are the way they are. Use profilers. See -prof or -lprof. I honestly prefer a sync profiler, which is my go-to tool literally for any performance work, at least as the starting point. Design factorial experiments, perform baseline and negative tests that provide experimental control, make sure the benchmarking environment is safe on JVM as hardware level, ask for reviews from the domain experts. Do not assume the numbers tell you what you want them to tell. So what it basically tells you that what you have is two numbers. but you cannot be sure that they're measuring what you want them to measure. For example, if you will get back to your benchmarks, and I'm not sure if it's the case because I need a profiler to tell you for sure, it might be the case that the input is really small. But what slows down the whole process is not the quadratic approach with a nested for loop, but the regular expression you're recompiling on each iteration. I know it's not the case because you pre-process your input, but it might be one of the reasons. So when you have two numbers, the second thing you're supposed to do with benchmarks is to understand why there is a difference. And for example, with negative experiment, if you know that that's a regular expression that contributes to a benchmark score, you comment it out, replace it with blank, and you rerun your benchmark and see that the score is now identical or not identical. So now you can be sure that you are measuring what you want the benchmark to measure.
Okay.
Because there's a lot of things happening in your benchmark. Like, it might be the case that in some specific code path you're allocating integers for some reason, and another benchmark you don't. That's what contribute the most to the slowdown.
Okay, yeah.
But here I'm pretty sure it's the quadratic nested for loop.
I mean, that's probably I'd also go out on a limb here and say that's fundamentally most likely the thing that makes the biggest impact. The numbers look very similar to using it or not using it, but I mean, it's still good that we're learning some best practices here. And I guess it's also very important for us to know. Maybe actually we'll spend some time on one of the future streams, like whipping out a profiler and actually maybe taking a look at some flame graphs, seeing where we do spend some time and whether we can approach it that way.
And I just like to brag about it. In JMH, there are two assembly profiles that work on OS X. The one is dtrace awesome that I contributed. And I think that was my test assignment to JetBrains. I showed it to Roman Yelizarov, and he was like, "Okay, you don't need a test assignment." And the second profiler, which I'm not get used to yet, and it's superior to what I wrote, I think it's Xtrace awesome. And it's written by Philip, the maintainer of KotlinXIO.
Wow. Okay, look at that. I feel like you deserve the bragging rights. That's amazing. That's really cool. Okay, but at least we kind of know a little bit of, if we wanted to have some performance investigations, JMH is kind enough to give us a little bit of a starting point of what we're actually supposed to do. We do know how to get just the numbers, which is quite delightful. I think we're pretty much done here for today. I'm always impressed by how much how many subjects spawn when you end up talking about a programming puzzle that takes a couple minutes probably to complete, and yet there's always still so many exciting things to be learned. I do want to round this out though by just trying for like a brief second and installing that specific Amper thing that you had in the beginning. I already have that open over here, and we linked it previously, but I'm also going to add this briefly. So as I understand this is just it's a homebrew tap, right? So it's just essentially another source for homebrew to find installation instructions from. Is that right?
Right.
Yep. Okay.
It could have been upstreamed, but I'm not sure if we're going to proceed with Amper, and for sync profile it's better to ask async profile maintainers. I'm just using it on my own.
Okay, understood. So here, I guess I can just grab myself this brew tap. I'm just going to open up a terminal here, and I'll add your tap with your extremely memorable username, which people can also find you on Twitter or Blue Sky if they manage to type that right. Right. So we just get a couple of extra formulas, and then I guess I can just hit the brew install Amper, right? Or does it need to be prefixed? Let's see.
No.
Downloading, installing.
And try to run Amper command right now.
Yep.
Yeah.
And now it downloads the actual...
Yeah, it downloads the actual binary of Amper from the JetBrains routing, so I don't do anything specific here. It's basically a glorified automated setup instruction. Yeah, now we have amper in your command line.
Okay, so now I can also do amper init, and I can now create myself a JVM CLI app. And I guess I can do amper run. And hopefully I'll get whatever the default hello world is inside there. And we'll have a build experience that never touched Gradle, that in this case never even touched IntelliJ. And that goes all the way through amper.
I wonder what is it? Yeah, hello world.
Nice. Hello world. Amazing.
It's still a bit too many seconds for that simple action, but we'll optimize it away because here we basically control the whole stack.
I'm very excited. But yeah, so I think this is the perfect way to round it out, because Advent of Code is all about trying out new things, solving some puzzles, and like upping your own skills in the language, the ecosystem, I don't know, how you use your tools, all these kind of things. So again, thank you to everybody who tuned in today. If you are as excited about Advent of Code as we all are at JetBrains, make sure you do stop by the blog post and check out everything that's been going on, because we have a template, we have leaderboards, we have ways of how you can win prizes without having to compete for a top spot, and we have a lovely community on the Kotlin Lang Slack that is also very excited to help, or that shares solutions that you can take a look at, where you can maybe find something new or discover a new approach to something. Once again, KotlinConf, the call for speakers is still open as our tiny little extra present for all of you. So if you have a talk, please make sure you submit it. It's going to be the event to be at if you are excited about Kotlin in 2025. And of course, if you want to ask Seva some more questions, I mean, you can find him on socials. But of course, you could also, for example, consider joining our asynchronous programming with Kotlin coroutines workshop, which is happening at KotlinConf, which the two of us will be giving. Yeah, so with that, I guess pretty much all that's left is to wait for 10 hours and 27 minutes until the next challenge arrives, and then the whole thing will start all over. So yeah, Seva, thank you so much for joining today. I really enjoyed having you.
Thank you. It was my pleasure.
Yeah. And of course, thank you to everybody who decided to tune in. We'll be back tomorrow at the pretty much exact same time. So make sure you hit that notify me button for all the upcoming streams to make sure you never miss any of them, including the ones that maybe happen a little bit earlier. We have a lot of guests. We have people from JetBrains coming in. We have people from the Kotlin leadership coming in. We have people from the community coming in. Old faces, new faces alike. It's going to be an absolutely amazing time. So thank you, everybody, for tuning in and spending this time with me. I hope that you'll have an amazing time with the challenge tomorrow, and we will see you then. Take care, everybody. Bye-bye.
Bye-bye.